Hello class, welcome to STAT 1200. I am your instructor William Gilman, and today we're covering section 8.4, hypothesis tests for a population proportion. Our objectives for today are to test a hypothesis about a proportion using the p-value method, and to test a hypothesis about a proportion using the critical value method. In a recent Gen X2Z American College student survey, 90% of female college students rated Facebook as cool. The other 10% rated it as lame. Assume that the survey was based on a sample of 500 students. A marketing executive at Facebook wants to advertise the site with the slogan, "More than 85% of female college students think Facebook is cool." Before launching the ad campaign, he wants to be confident that the slogan is true. Can he conclude that the proportion of female college students who think Facebook is cool is greater than 0.85? This is an example of a problem that calls for a hypothesis test about population proportion. We use the following notation. P is the population proportion. Of individuals who are in a specified category. X is the number of individuals. In the sample who are in the specified category. N is the sample size. P hat is the sample proportion. Of individuals who are in the specified category. P hat is still X over N. So these should all look familiar because it's the same notation we use for confidence intervals. In order to use a population proportion, we have some assumptions. The method for performing a hypothesis test about a population proportion requires that the sampling distribution be approximately normal. In order to do that, we have to ensure that the following assumptions are met. We have a simple random sample. The population is at least 20 times as large as the sample. The items in the population are divided into two categories. The values n times p naught and n times 1 minus p naught are both at least 10. For the p-value method, you're going to do these 6 steps. First, we state the null and alternative hypothesis. If we're going to make a decision based off of this, we have to choose a significance level, or you will be given one in a quiz or an exam or something like that. Compute the test statistic, z, which is equal to p hat minus p naught divided by the square root of p naught times 1 minus p naught divided by n. Compute the p-value, so if it's a left-tailed test, the p-value is the area to the left of z. If it's a right-tailed test, the p-value is the area to the right of z. And if it's a two-tailed test, the p-value is the sum of the areas to the left of negative z and to the right of positive z. Step 5, interpret the p-value. Again, if making a decision, reject the null if the p-value is less than or equal to the significance level of alpha. And finally, state your conclusion. So example 1, we're going back to that Facebook study. So we have the whole same setup. So now let's go into our assumptions. We have a simple random sample, check. The sample size of female college students is probably 20 times greater than the sample size of 500. So is there more than 10,000 female college students? Yes, that seems reasonable, check. The proportion specified by the null hypothesis was p naught equals 0.85, so we're going to check that. So now if we take our sample size times that initial population proportion, we get 500 times 0.85 which is equal to 425, which is greater than 10. And now we need to check the other one too, n times 1 minus our population proportion, which gives us 500 times 1 minus 0.85, which is equal to 75, which is also greater than 10. So we have shown the assumptions are met, we may proceed. Our null hypothesis was that p is equal to 0.85, and our alternative hypothesis that is greater than that, so p is greater than 0.85, because they want to know if more than 85%. The sample proportion p hat was 0.90. The value of p specified by the null hypothesis was, as said earlier, 0.85. The test statistic is the z-score of p hat, which is given by z, which is equal to 0.90 minus 0.85 divided by the square root of 0.85, 1 minus 0.85 over 500, which is equal to 3.13. So, since this is a right-tailed test, we need to find the area to the right of z equaling 3.13. We use table A2 to find this area, which we find as 0.0009. Since p is less than 0.05, because 0.0009 is less than 0.05, we have to reject the null hypothesis at the alpha equals 0.05 level. And thus, we can conclude that more than 85% of female college students think Facebook is cool, so the marketing executive can use that slogan. What if instead of using the p-value method, we want to use the critical value method? This is how you do it. Again, you state the null and alternative hypothesis, we choose an alpha, we compute the test statistic z, we determine whether or not to reject the null by using the following. If it's left-tailed, we reject if the test statistic is less than or equal to the critical value. If it's right-tailed, we reject if the test statistic is greater than or equal to the critical value. Two-tailed, reject if z is greater than or equal to z alpha by 2, or if z is less than or equal to negative z alpha by 2. So make sure you correct that in your notes, because I know it in your notes it's wrong, so make that correction. And finally, state a conclusion. An example using the critical value method, example 2. A nationwide survey of working adults indicates that only 50% of them are satisfied with their job. The president of a large company believes that more than 50% of employees at his company are satisfied with their jobs. To test his belief, he surveys a random sample of 100 employees, and 54 of them report they are satisfied with their jobs. Can he conclude that more than 50% of employees at his company are satisfied with their jobs? Use the alpha equals 0.05 level of significance. Again, as always, we first check assumptions. So always check your assumptions first, because if your assumptions aren't valid, your hypothesis test won't be valid. Don't even continue. So always, always, always check your assumptions. We have a simple random sample, check. The sample size n is 100, and the proportion specified by the null is 0.05. Therefore, we have the sample size times the initial population proportion is 100 times 0.5, which equals 50, which is greater than 10, and that the sample size times 1 minus the initial population proportion is 100 times 1 minus 0.05, which also equals 50, which is greater than 10, so that assumption is checked off. If the total number of employees in the company is more than 2,000, which we're going to assume for this example, then the population is more than 20 times as large as the sample, so that assumption is checked off. All assumptions are now met. The null hypothesis is that the population proportion is equal to 0.5, and the alternative hypothesis is that it's greater than 0.5. So again, this is a right-tailed test. The critical value z alpha is equal to 1.645 that's for at 0.05, we can find that critical value is 1.645. Recall that p hat, the sample proportion, was 0.54. Thus, our test statistic is going to be equal to z, which is 0.54 minus 0.5 over the square root of 0.51 minus 0.5 divided by 100, which gives us 0.80. So because this is a right tail test, we reject if our null hypothesis if our test statistic is greater than or equal to 1.645. Because 0.08, our test statistic, is less than our critical value of 1.645, we do not reject the null hypothesis. So what does that mean? Okay, here's our big finale. This is always what we want, or stating our final conclusion. This is a really important part of hypothesis testing. There is not enough evidence to conclude that the company's president is correct in his belief that the proportion of employees who are satisfied with their job is greater than 0.05.